So let's talk about incomplete dominance. What we were talking about before was dominant means you had one or the other. They're both dominant at the same time, so both traits are showed. So in plants, it's a little easier to see, and then we'll talk about some human examples. We have a red plant, and we cross it to a white plant. This is a snapdragon. It's a type of flower. You cross them together, and you get this intermediate pink. Now, when we were doing our past examples, we knew that if you took a dominant and a recessive and put them together, we should get all dominant. But here, we're seeing this intermediate kind of thing. So it's almost like you took a bucket of red paint and a bucket of white paint, and you mixed them together, and you ended up with pink. And that's kind of what happened here, is that I would have to tell you in the question that this is incomplete dominance, unless it's something that we're going to go over now, then you should just know. But basically what you see is that when the pollen and everything came together for the plant, we ended up getting this sort of intermediate sort of thing, where we get the dominant would be big R, big R. The pink, the only way you could get a pink is if it's big R, little r, and white would be little r, or whatever you designate these letters to be. You can make them whatever you want. Really, what I'm going to be asking you for is the stats. Is it 50%, phenotype, genotype, whatever? But let's do the one that is most important in humans, and that's going to be blood typing. Codominant and incomplete dominance are the same sort of terms. You might see them a little bit here and there, but that means you can have one copy or two copies and they're both going to show. If you hear about somebody having these types of blood types, what that means is blood type A could be A, which means they got a copy from mom and a copy from dad, or they could be A and O. So that means they got a copy from mom and a copy from dad, but one was the A gene, one was the O, which means nothing. With B, you could have two copies of the B or BO. With AB, you could have a copy of A and B, and O means you don't have any markers on your blood, and markers would be something like this, where you have a little sugar on the outside of your blood that indicates who you are. So this is going to be blood type A, and they have a certain sugar. Blood type B has a different sugar. AB has a mixture of the two sugars, and O has no sugars. So antibodies are the thing that they make that are looking for the opposite. So for instance, somebody with blood type A should never have blood type B in their blood. So what happens is they make this thing called an antibody for the B blood, and what it's doing is anytime it ever sees B blood, it's going to attack it. So anytime it sees this sugar. So can you see how this sugar is right here with blood type B? Can you also see that it's here too with AB? Even though this sugar and this sugar are the same, it also has this foreign sugar on it. And because it's got this foreign sugar, it's going to attack it. And then O has no sugars on it, so we don't have any antibodies that are going to attack O, so everybody can take O's blood. So let's talk about it a different way. You could see that when we talk about these blood types, we talk about phenotype. Phenotype is going to be the AB, or O, and genotype is just diving in a little more to see what are the actual genes that they have. Because blood type A could be AA or it could be AO. Blood type B could be BB or BO. The only one that we know for a fact without even doing a genetic test is going to be this one. If you're blood type AB, that means you have a copy of A and B. And also the other one that we'd know genetically without doing a test would be this one, blood type O. It would mean that you have no sugars on the outside, so OO. So these are the only ones. If we really needed to know genotype, we'd have to do some genetic testing. So what we do want to do is figure out how we can donate blood to people and who we can receive blood from, because as a nurse, you're going to have to do this all the time. So, and what we're really kind of thinking about are these antibodies, because we want to make sure that when we give the person blood, these antibodies don't get in the way. And now you could see with this antibody that if you give this person, blood type A, anything with a B in it, this or this, there's going to be a problem. With blood type B, you could see the same sort of thing is going to happen. If you go ahead and give this person anything with an A, this one or this one, we're going to have a problem. We go ahead and when we can, but let me rephrase this. If you go ahead and give AB, A, is there going to be a problem? No, because there's no antibodies. With B, is there going to be a problem? Again, no, because there's no antibodies. If this produced an antibody A and an antibody B, would there be a problem? Yes, there would be, because what would happen is it would attack itself. So this person doesn't have an antibody. Person O has no sugars on the outside, so it's going to find A foreign, it's going to find B foreign in its body, and that's why it produces the antibodies for A and B. So when we talk about these two groups in particular, we talk about AB being the universal recipient, because they can take blood from A, B, and O, and we call O the universal donor, because they can give it to AB, B, and A. We threw in one extra thing in our class. It was the RH factor. Remember the positives and the negatives? And that's just one extra sugar that these guys have. If they have the positive sugar, it's just going to be out here. If they have the RH negative, they're not going to have any sugar at all. So that's the one extra thing we have to think about when we give out blood. Who can we give it to? Who can we receive it from? Why don't I go ahead and let's do one here. So you have an A RH plus person, and who can they receive blood from? So that means who can they get blood from? So we can go ahead and get blood, or we can give blood to this person. We can give it to them from A plus, right? We can do A minus, because they don't have that RH factor. We talked about that in class. We can do O plus, and then we could do O minus. Can we do AB? No, we can't do AB because of the B sugar. Great, let's do one more. Let's do B plus. Oh, let's do B minus. That's even harder. So who can they get blood from? They can obviously get blood from B minus. Can they get blood from B plus? B-wise, they'd be fine, but the positive would be the problem. So they can't get it from B plus. Can they get it from O minus? Okay, they can get it from O minus. Can they get it from O plus? No, because the plus would be the problem. So this is the only guys they can get it from. If we change this to B plus, we can have a couple more options, because we can now get blood from B plus and B minus. What about AB? Plus or minus? No, we can't, because remember how the A will be the problem. So, good. And we made a little chart for that, so that might help.